One of the most important properties of the atmosphere is air pressure. Motion in the atmosphere is initiated by differences in temperature. To investigate the concept of air pressure, we will use the AMS pressure blocks and 2 index cards. Whether tall or short, the blocks used in this demonstration have the following characteristics. All blocks have the same weight regardless of the volume they occupy. All blocks have the same size square base. All individual blocks exert the same downward pressure on the surface beneath them. Red blocks represent warm air, while blue blocks represent cold air. Take one block from each color set and place it on its square base on a table surface. Because both blocks weigh the same and their bases have the same area, the blocks exert the same amount of pressure on the table. The shorter blocks occupy half the volume of the taller blocks, while containing equal masses. We know this because they weigh the same. Because density is mass per unit volume, the smaller blocks are twice as dense as the larger blocks. This means that cold air is more dense than warm air. Place another identical block on top of each block already on the table. Each stack is now exerting twice the amount of pressure on the table as the single blocks did initially. The pressure exerted on the table by the tall stack is equal to the pressure exerted on the table by the short stack. Position the 2 stacks side by side and add another identical block to each stack so that there is a total of 3 in each. Insert an index card horizontally through the 2 stacks so that the 2 shorter blocks and 1 taller block are positioned beneath the card. Compare the pressure exerted on the card by the overlying blocks. The taller block stack exerts greater pressure on the card than the shorter block stack. Add a short block to its respective stack. Lift the top tall block and overlay the stacks with another index card. Now add the rest of the blocks to their respective stacks. The pressure exerted on the table by the tall stack remains equal to the pressure exerted on the table by the short stack. Notice on top of the card there are 3 tall blocks of pressure and 1 short block of pressure. The total pressure on the lower card is 4 tall blocks and 3 short blocks. On the table, there are 5 tall blocks of pressure and 5 short blocks of pressure. If you think of the index cards as horizontal surfaces in the atmosphere, you can see that pressure decreases more rapidly with height in the shorter, more dense stack of blocks. Therefore, pressure decreases more rapidly with height in a column of cold air than in a column of warm air. This has been a presentation of the American Meteorological Society.